Hello, good day to each and everyone. I am Batingolo and I'm going to present my activity 6, which is titration. So before that, let me state first my objectives for today's presentation. First, to properly understand what is a titration. Second, to know what are the steps for carrying out a titration. And the last but not the least, to know what is the purpose and the types of a titration. So without further ado, let's begin. So let me define first what is a titration. So, titration is the slow addition of one solution of a known concentration called a titrant to a known volume of another solution of unknown concentration until the reaction reaches neutralization, which is often indicated by a color change. The solution called the titrant must satisfy the requirements to be a primary or secondary standard. In a broad sense, titration is the technique to determine the concentration of an unknown solution. So, the titrant is the end product. So, let's move on in the types of titration. There are many types of titration when considering goals and procedures. However, the most common types of titration in quantitative chemical analysis are redox titration and acid-base titration. Titrations can be classified as acid-base titrations, redox titrations, precipitation titrations, and the last one is the complexometric titrations. So let's discuss it one by one. So first, what is a acid-base titration? So it is a quantitative analysis method to determine an acid's or base's concentration by precisely neutralizing them with a standard solution of either acid or base of known concentration. It is monitored with the help of a pH indicator to know the development of the acid-base reaction. So the second one is the redox titrations. The redox titration is also known as an oxidation-reduction reaction. In this type of titration, the chemical reaction takes place with a transfer of electrons in the reacting ions of aqueous solutions. The titrations are named after the reagent that is used in are as follows. So the first one is the permanganate titrations, the second one is the dichromate titrations, and the last one is the iodimetric and iodometric titrations. So the first one is the permanganate titrations. So in this titration, the potassium permanganate is used as an oxidizing agent. It is maintained with the use of dilute sulfuric acid. So the second one is the dichromate titrations. These are titrations in which potassium dichromate is used as an oxidizing agent in an acidic medium. The medium is maintained acidic by the use of dilute sulfuric acid. So the last one is the iodimetric and iodometric titrations. So it is the reduction of free iodine to iodine ions and oxidation of iodide ions to free occurs in this titration. So the third type of titrations is the precipitation titrations. The titration is based on the insoluble precipitate formation when the two reacting substances are brought into contact are called precipitation titration. For instance, when the solution of silver nitrate is used to a solution of ammonium thiocyanate or sodium chloride, it reacts and forms a white precipitate of silver thiocyanate or silver chloride. So the last type of titration is the complexometric titration. The complexometric titration is where an undissociated complex is formed at an equivalence point. It is greater than the precipitation titrations and there will be no error due to co-precipitations.
A titration is a technique used to work out the concentration of an unknown solution. When you know the concentration of other solution, you carefully add the known solution to a said volume of the unknown solution until the reaction is complete. This enables you to work out the concentration of the unknown solution. You may need to use an indicator to signal the end of the reaction. You can calculate the concentration of an acid or alkali by carrying out a titration experiment. In this video, we are going to look at how to carry out titrations. An apparatus needed for titrations looks like this. The pipette is used to accurately measure a certain volume of the unknown solution into the flask. Burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The bread can measure up to a 0.05 cubic centimeter accuracy. To carry out a titration, you follow these steps. Okay, so first, using the pipette, add a set volume of the unknown solution to a clean conical flask. Second, you may also need to add a few drops of indicator. Then, third, fill the burette with the known solution. And make sure it is leveled off at exactly 0. Fourth, slowly add the solution from the burette to the unknown solution in the conical flask. Fifth, you may need to swirl the flask to mix or use a stir plate. Sixth, stop adding when the reaction is complete or the endpoint is reached. There is where indicator may help you because there would be an appropriate color change. Seventh, record the final volume on the burette. This gives you the volume of the solution added. This volume is called the titer. 8. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titer. Depending on the indicator you use, the color change will be either gradual or sudden. If you're carrying out an acid-alkali hydration, you may use a universal indicator, which would give you a gradual color change. This might not be ideal because of this gradual color change. Litmus gives you a sudden color change. But there are other best indicators that are specialized for the acids and the alkalis in the titration. Sometimes the acid may be the known solution and the alkali is unknown. And other times, the alkali is the known and the acid is the unknown.
So for generalization, titration isn't just an experiment you need to perform to pass chemistry in school. It has many important applications in everyday life, making it an indispensable analytical tool and quality control test. For instance, a food processing company might use titration to calculate the precise amount of salt in a particular foodstuff. It can also be used to determine the concentration of vitamin C or vitamin E additives in foods. These factors not only determine the taste and nutritional value of the food products, but can also affect the aesthetic of them. For example, the concentration of additives directly impacts the overall color of a food product. So that would be all. I hope you learned something from me. So see you guys in the next video.